Welcome to this exploration into one of science's most fascinating possibilities, time travel. Today, we're going to delve into the science, theories, and concepts behind how time travel could be possible. Over the next 10 minutes, we'll explore ideas from Einstein's theories of relativity, quantum mechanics, and even some mind-bending thought experiments that challenge our understanding of reality. Let's begin with a basic understanding of time. We experience time as a continuous flow, a sequence of moments that move from the past, through the present, and into the future. But what if time isn't as rigid as we believe? Many scientists argue that time could be more like a dimension, similar to the three spatial dimensions we move through every day. This idea opens the door to the possibility that time travel might not be purely science fiction after all. One of the foundational theories in modern physics is Albert Einstein's theory of general relativity. In his revolutionary work, Einstein showed that space and time are woven together into a four-dimensional fabric called space-time. According to general relativity, massive objects like stars and planets can warp space-time, much like a heavy ball placed on a stretched rubber sheet. This curvature is what we perceive as gravity. Now, imagine if this curvature could be manipulated in such a way as to create shortcuts through time. In theory, if space-time can be bent or twisted enough, it might be possible to connect two separate points in time with a bridge, often referred to as a wormhole. Wormholes are hypothetical tunnels that connect distant parts of the universe, or even different times. While no one has ever observed a wormhole, they remain a popular theoretical construct in the physics community because they emerge naturally from the equations of general relativity. Another fascinating concept arises from the phenomenon known as time dilation. According to Einstein's theory of special relativity, time doesn't pass at the same rate for everyone. When an object moves at speeds close to the speed of light, time slows down for that object relative to someone who is standing still. This is not just a theory, it has been confirmed by experiments using precise atomic clocks on fast-moving jets and satellites. So, if an astronaut were to travel in a spacecraft at near-light speeds and then return to Earth, they would find that time on Earth has passed much more quickly than the time they experienced. In effect, they would have traveled into the future relative to those who stayed behind. This is one of the few ways we know that time travel, at least into the future, is scientifically plausible. Beyond these ideas, some physicists have explored even more exotic scenarios. One of these is the concept of closed timelike curves. A closed timelike curve is a path in space-time that loops back on itself, meaning that an object traveling along this path could theoretically return to its own past. The mathematics of general relativity allows for the possibility of such curves under very specific conditions. However, this idea leads us directly into one of the most perplexing challenges of time travel: the paradoxes. Perhaps the most famous of these is the grandfather paradox. Imagine if you traveled back in time and intentionally or unintentionally prevented your grandfather from meeting your grandmother. Without that meeting, you would never have been born. Which raises the question, if you were never born, how could you have traveled back in time in the first place? While these paradoxes might seem to undermine the possibility of time travel, some scientists have proposed potential resolutions. One possibility is the idea of parallel universes or multiple timelines. According to this hypothesis, if you were to change events in the past, you would not affect your original timeline, but instead create a new branch of reality. In this new branch, the events unfold differently, and no logical contradiction occurs in your original timeline. Quantum mechanics also enters the conversation when we consider time travel. Quantum theory has revealed that at a very small scale, the behavior of particles is governed by probabilities rather than certainties. Some interpretations of quantum mechanics suggest that all possible outcomes of an event exist simultaneously, which is known as the many worlds interpretation. In this framework, every decision or random event spawns a new parallel universe. If this is true, then traveling back in time might mean arriving in a different universe where events have unfolded differently from what you remember. Although this is an intriguing idea, it remains speculative and is still a subject of intense debate among physicists. Another theory that has captured the imagination of both scientists and science fiction writers alike is the Tipler cylinder. This is a theoretical solution to the equations of general relativity that involves a massive, infinitely long cylinder rotating at near light speed. According to the theory, such a cylinder could create a region of space-time that loops back on itself, allowing for time travel. However, there are significant practical and theoretical challenges with this concept, not least of which is the requirement of an infinite cylinder and the enormous energy needed to set it rotating at the required speed. While the mathematics and theories behind time travel are fascinating, it's important to note that we currently have no experimental evidence that time travel is possible. The ideas we've discussed remain in the realm of theoretical physics and speculation. Even if the math works out, the engineering challenges of constructing a device capable of bending space-time or achieving near-light speeds are astronomical. Despite these challenges, research into time and space continues to push the boundaries of what we understand about the universe. Advances in technology, such as more powerful particle accelerators and more sensitive detectors, might one day provide us with new insights into the nature of time. Perhaps in the future, experiments could reveal phenomena that hint at the existence of wormholes or other exotic space-time structures. Until then, the possibility of time travel remains one of the most intriguing mysteries in modern science. As we consider these possibilities, it's also worth reflecting on the philosophical implications of time travel. If we could travel through time, what responsibilities would come with such power? How would our understanding of cause and effect, free will and destiny change? These questions have not only inspired scientists and philosophers, but also countless works of fiction, from novels and films to television series and video games. Each narrative explores different aspects of time travel, reflecting our deep curiosity about the nature of reality and our place within it. In summary, while time travel remains a concept that is more at home in science fiction than in practical engineering, the scientific theories that hint at its possibility are grounded in some of the most robust ideas in modern physics. From the warping of space-time by massive objects to the counterintuitive effects of time dilation and the perplexing ideas from quantum mechanics, the pursuit of understanding time itself continues to captivate the human imagination. Thank you for joining me on this journey through the theories and possibilities of time travel. Whether it's the future or the past that intrigues you, the exploration of time reminds us that there is still so much to learn about the universe. If you enjoyed this deep dive, consider subscribing for more explorations into the mysteries of science, technology, and the cosmos. Until next time, keep questioning and keep exploring the wonders of the universe.